Hi guys, this is lesson 6.4. It's called Elimination Using Multiplication. So remember that systems are all about combining different pieces of information. Those pieces of information, when we graph them, make lines on a graph because we're studying linear equations. Not all situations make lines, but in this chapter we're only dealing with lines. And they're about combining different pieces of information to come to a conclusion. The conclusion is usually the place where the two lines intersect. And so far we have solved systems like this by graphing and looking at the lines and where they cross. We have used substitution, where we solve for one variable and plug something into the other equation and solve that way. And we have used elimination, where we add the two equations together and cancel out a variable. So now we're going to get a little more aggressive. We're going to use multiplication to force our equations to cancel a variable when we add them. So we have a situation here. The table shows the number of cars at Scott's Auto Repair Shop for each type of service. The manager has allotted 1,110 minutes for body work and 570 minutes for engine work. The system, 3R plus 4M equals 1,110 and 2R plus 2M equals 570 can be used to find the average time for each service. So that's what I told you about. We have different pieces of information. We need those pieces of information to come together so that we can solve something. But notice what happens if I'm looking at 3R plus 4M equals 1,110 and 2R plus 2M equals 570. So we are not solved for one variable to easily use substitution, so that's fine. It's not what we're talking about today anyway. And we are not set up to add these things together and have anything cancel out. So if I were to add them together, frankly, I would get 5R plus 6M equals 1,680. And that doesn't help at all because we didn't cancel out a variable. So what we're going to do today is we are going to multiply at least one of the equations by something that causes us to get opposite terms that will be eliminated when I add them together. So we're doing the same thing we did in the last lesson, but we're just going to do a little bit of manipulation to multiply one of our equations and make it so that it will cancel. Okay, here is a little more of an example. We have 5x plus 6y equals negative 8 and 2x plus 3y equals negative 5. And notice if I add them together, nothing cancels. So what they're going to do is they're going to multiply each term in the second equation by negative 2. If I multiply 2x times negative 2, I get negative 4x. If I multiply 3y times negative 2, I get negative 6y. And if I multiply negative 5 times negative 2, I get a positive 10. So they line these all up and then add them together. And notice that 5x plus negative 4x gives us a positive x. Great, just x. And then 6y and negative 6y cancels. And then negative 8 plus 10 gives us 2. So we actually got to x equals 2 all in one step without even having to finish solving it. That's cool. So we're going to take that x equals 2 and plug it into the one of the equations, either one, it doesn't matter, and then solve for the y equals negative 3. All right, here's a situation where we're going to multiply each of the equations by a number, and they don't have to be the same number. We're going to multiply our 4x plus 2y equals 8 by 3. And that gives us the 12x plus 6y equals 24. And then we're going to multiply our 3x plus 3y equals 9 by negative 4. And we did that to get negative 12x minus 12y equals negative 36. So we were looking at trying to get these two guys to cancel, and the rest of it we just sort of take what we get and deal with it. Obviously not everything is going to suddenly cancel. So when we add those things together, we get negative 6y equals negative 12. Finish solving that to get y equals 2, take the y equals 2 and plug it into one of the equations to finish solving for x. All right, here they show in method 2 another way of doing it, okay? So we don't have to do it with the 3 and the negative 4. We could multiply the top one by 3, okay? That's similar. And then we could multiply the bottom by negative 2. And instead of making the 12x and the negative 12x like it did in the first example, we end up with the middle terms here ready to cancel, a positive 6y and a negative 6y. All right, here is a word problem. A personal aircraft traveling with the wind flies 520 miles in 4 hours. On the return trip, the airplane takes 5 hours to travel the same distance. Find the speed of the airplane if the air is still. Okay, so what they have done is they set up a neat little system, and they said that 4a plus 4w equals 520. That a is the rate of the airplane when the air is still, and w is the rate of the wind. And so we had the first situation, 4a plus 4w equals 420, and then on the way back we had 5a minus 5w equals 520. And so if we line those all up, they are already lined up. You can see that they don't cancel. That doesn't cancel, that doesn't cancel, that doesn't cancel. Actually, it does, but it doesn't have a variable, so that doesn't help us at all. So we're going to multiply the first one times 5 and get 20a plus 20w equals 2,600. And we're going to multiply the second one times 4 to get 20a minus 20w equals 2,080. And then we have the middle terms all set up to cancel. So we end up with 40a equals 4,680. And we can finish solving. We have found out that the rate of the airplane in still air is 117 miles per hour. And that's actually what the question asked for up here. If the question went on to ask us for the rate of the wind, we could solve for that as well. Okay, let's work a couple of problems. 2x, you write this down because I'm going to let you try it, minus y equals 4. 7x plus 3y equals 27. We want to make these guys so that they will cancel. So you're going to choose something to multiply by and then add them together to finish solving. Pause the video, try it, see when you get stuck, and then you can jump back in. All right, so what I'm going to do is I'm going to multiply this equation right here times 3. I'm going to do that because if I multiply by 3 here, I'll get negative 3y to add to my positive 3y. So that would equal 6x minus 3y equals 12. I'm going to keep the bottom one the same this time, and I'm going to add those two equations together to get 13x. This entire thing canceled, which is lovely, equals 39. Right now I could have written the plus 0 if I wanted to. I don't have to. 13, I'm going to divide by, and I end up with x equals, I bet 13 goes into 39 3 times, nice and equal. So let's take our x equals 3 and plug it into any one of our equations. So I'm going to use the 2x minus y equals 4. So I'm going to go 2 times 3 minus y equals 4. 6 minus y equals 4. Oh, I hate having minus y, so let's go ahead and just do plus y. I'm going to need it to be positive, and so I can subtract 4 to get that to go over here on the other side, and I get 2 equals y. So I have an answer. My x is 3 and my y is 2. All right, let's try another one. These just take some practice, and they're a little like puzzles. There's more than one way to do them. All right, let's start with 2x plus 7y equals 1, and x plus 5y equals 2. Again, pause the video and try it yourself, and then come back. I am going to multiply this entire second equation by -2. I'm going to get -2x minus 10y equals -4. I'm going to keep my top one the same. It is 2x plus 7y equals 1. I'm going to add those two together. This is 0. 7 and -10 are going to give me -3y equals -3. 1 plus -4. All right, so I have -3y equals -3. I need to divide by -3 to get y by itself. Y equals a positive 1. -3 divided by -3 is positive 1. I'm going to take my y equals 1 and plug it into something. So I think I'll use the second equation in its first form. I've got x plus 5 times 1 instead of y equals 2. 5 times 1 is just 5, so I'm going to subtract 5 here. X equals a -3. So my final answer is x is -3 and y is 1. Okay, let's do another one. 4x plus 2y equals -14. 5x plus 3y equals a -17. Go ahead and stop the video, see if you can do it. Come back when you either get stuck or when you're finished. I'm going to choose to multiply the top times 3 and the bottom times 2. Are there other things you could do? Yes, you could multiply the top times maybe 5 and the bottom times -4. There are infinite possibilities, actually. I'm just looking for something that makes sense to me. Okay, so if I multiply the top times 3, I'm going to get 12x plus 6y equals 30, and 12 is 42, so -42. And for the bottom, I'm multiplying times 2, so I get 10x plus 6y. Let's multiply by -2. So I get -10x, and I get -6y equals, let's see, positive 34. Correct, 14, okay. So I'm going to add these two together to get 2x, positive 12 and -10. And then 6y and -6y cancel. -42 and 34 makes a -8. 6, 7, 8. So I have 2x equals -8. I'm going to divide by 2 to get my x by itself. X equals -4. And I need to take my -4 and plug it into one of these equations. 4 times -4 plus 2y equals -14. -16 plus 2y equals -14. I'm going to add 16 in my quest to get y by itself. That's a positive 2. And oddly enough, this is actually going to end up being quite simple and not a messy number at all. Right, so I have a final answer of -4 for x and 1. Very nice. I'm going to do one more practice. 9a minus 2b equals -8, and -7a plus 3b equals 12. Go ahead and pause the video, see if you can solve it. I am going to choose to multiply the top times 3 and the bottom times 2. So I'm going to end up with 27a minus 6b equals -24. And then for the bottom one, I'm going to end up with -14a plus 6b equals 24. Okay, I'm going to add those two equations together. 27 minus 14, 27 plus -14 gives me 13a. And -6b and +6b are 0 equals -24 plus 24 is 0. And so when I divide by 13, it's okay to divide by a number. It's just not okay to divide by 0. A is going to equal 0. All right, I've got to take my a equals 0 and plug it in somewhere. So I'm going to go 9 times a minus 2b equals -8. So I have 0 minus 2b, which is minus 2b, equals -8. Divide by -2 and get b equals 4. All right, so I have a final answer here. A is 0 and b is 4.